Hello, in this video we're going to continue our introduction to objects and classes by actually writing our first class. We're going to pick something simple. We're going to write a fraction class, which is going to allow us to put fractions into our program and use them in some meaningful manner. So what I have on the screen here is part of my Eclipse screen, and I'm going to use specifically this project, Introduction to Classes. So I'm going to right click it, I'm going to say New, I'm going to make it a class, and this first class is going to be fraction. This class is not going to have a main method in it. This class is going to be used to create fraction objects. This is going to be my blueprint that I use to make all the different fraction objects I might use. I'm going to hit finish. So here it is, my class header, and class. And we'll just put some space in there. I'm also going to make a second class, and this is going to be called fraction runner. Fraction runner is what I'm going to use to test my class. Remember, the whole point of making classes to create these objects is that any class could use the fraction class once I've created it. Fraction runner is one class that is going to use fraction class. Because it's going to be my testing class, I'm going to need a main method in it. So we're going to hit finish, and there it is. So let's go end class, end main. So let's go in and let's design our fraction. Remember, when we think of an object, we ask ourselves, what are the attributes and behaviors? So my question to you is, what if you were to describe a fraction to someone, what would you tell them? You would probably tell them what the numerator and the denominator is. So then my second question is, what type of variable would you make a numerator and a denominator? And I'd probably make them an integer. So we're going to declare two fields here, int num and int denominator. Let's get rid of these actually. So this stores the numerator value, and this stores the denominator value. So these are our fields. Notice I haven't actually assigned them a value yet. A class is a blueprint. Every fraction that is created now will have two fields, a numerator and a denominator. Each instance could have a different value in here, so there's no point at this point to give these values. The general anatomy of a class is we have fields, followed by constructors, followed by methods. Now we haven't actually talked about constructors yet, and we're not going to include any, but know that there is a default constructor built into every class when you don't define one. And that default constructor will set all our numerical values to 0, doubles and ints, reference types to null, characters to a special character, and strings to null as well. So now let's go into fraction runner and let's create a couple fractions. Let's save everything first. So I can now say fraction f1 equals new fraction, fraction f2 equals new fraction. I've now created two fraction objects. And let's move this window over here because we don't need to actually go over there anymore. I've created now two fraction objects, and now I can assign values. f1.numerator equals 1, f1.denominator equals 2, f2.numerator equals 3, and f2.denominator equals 4. So there we have two fraction objects, f1, f2, and we've assigned their values. Notice, to access numerator and denominator, we need to specify which specific object we are setting the value for. So it's an important point to note out that if I do a print line like this and run this, so let's run this program, notice I don't actually get the values in numerator and the values in denominator. What it prints out for me is a reference. Objects are reference variables, meaning that you store a reference to where the data is located. So if I try and print out the name of simply print out the object this way, I am going to actually end up printing out the reference. Now it is good to point out there is a way around this, but at this point we don't have that. So when we look at this value, this is the memory location of where the object is stored, and this is telling us what is the object type that is stored at that memory location. Remember, when we declare objects, the left side is the reference type, and the right side is the object type. These are always going to match at this point. Eventually they won't, so it's important that we distinguish. Left side is reference type, right side is object type. So let's come into our fraction class, and let's write a method here. Maybe what I want to do is I want to calculate, maybe I want to multiply the fraction by something. So we're going to make a method called, an instance method called multiply. So we're going to say public, it's an instance method, so there's no word static, and we're going to say multiply, and we're going to take an integer that is going to be what we multiply by. Oh, we forgot a return type. Here we go. So this method takes an integer value and multiplies the implied fraction, the implied object, by that value. So our parameter is int a, and there's no return type. So if we think about how the operations of fractions, if we multiply a fraction by a constant, we're going to multiply the numerator by that much. So all that we're going to write in here is num equals num times a. And this is the multiply. So now we can save them all. I can come into my fraction runner, and let's take out this line here. And I can run this, it runs fine. Let's print out f1.num, f1.denominator, and now let's call this method. Let's multiply f1 by, say, 5. So we go f1.multiply, and notice now when I type in Eclipse, I type in the object, it actually tells me some fields. We have denominator, we have numerator, the two fields that each fraction has. And then there's all these methods. Now, we won't talk about why it has all these methods already, but there is a reason for that. But there's the method we wrote, multiply. So we're going to say multiply, and we're going to multiply it by 5. So again, let's highlight the important ideas in this line. f1 is the implied object. That is the object that is being multiplied by. That is actually, when I go to the multiply method and look, if I come in here and look, I'm going to imagine that num is f1's num. So if a is 5, it's going to say whatever the numerator is times 5, and then it's done. If I run this, it prints out f1 num as 1/2, and then it calls f1.multiply, and it prints it as 5/2. We do not have to return anything. Because objects are reference types, any changes that happen are going to be reflected outside of that method. If I want to multiply f2, I could say f2.multiply. Let's multiply it by 100. And I could say, this is no. And now if I want to print out f2, I'm going to say f2.num, f2.num. And there's f2. Now I really want to highlight the idea here at this point is that I'm actually using I'm doing some bad programming here. I'm accessing the fields using directly. There actually should be a method we use to access these, and all these fields should be private. Currently they're public, but we'll talk about that in our encapsulation video. Let's write one more instance method in here. Let's write an instance method that's going to multiply a fraction by a fraction. Public void, and let's call this multiply fraction. And we're going to take a fraction object and we'll call that f. and we're going to say num is equal to this dot num times, and actually let's call this other dot num, and denominator is equal to this dot denominator times other dot denominator. What's really important to understand here is that even though I only have one object written, there are actually two objects when this method gets invoked. There's the implied object, and there's the past object. This is a reserved word used to talk about the implied object. It's not actually necessary here. I could simply say num times other dot num, because we'll assume that if we write num, we're talking about the implied object. And so typically we don't write this in that case. So this is going to take a past object, multiply it by each part by the implied object's part, and then end up with a new implied object. Notice we're changing the implied object here. So we come to fraction runner. I could do something like f1 dot multiply by fraction f2. And what we want to understand here is that f1 in this case is the implied object, and f2 is the past object. And when this is done, f1 will be modified. So if I say system dot, let's just take this and we'll just cut and paste, just a time, and we're going to say f1, and in fact let's take these and we're going to delete those for now. So if I run this, we're going to, f1 is going to get the value 1 over 2, f2 is going to get the value of 3 over 4, and then we're going to multiply f1 by f2. But when this is done, f1 will be modified. So if we run this, f1 is 3 over 8, and f2 remains at 3 over 4. If I reverse these, f2 is now the implied object, and f1 is the past object. And therefore, f1 remains the same, and f2 changes. I can't stress enough, the best way to understand this concept is to write some little examples yourself. So play around, and as always, if you have questions, just ask or post them on my channel. Have a great day.